last class we have studied energy signal and power signal. So in this class and we have solved a problem based on energy and find the energy and power of the signal. But there we have seen that we need the formula for geometric progression, infinite series geometric progression, and for finite series geometric progression the formula we need. So finally the formula which is very important and we are going to use that formula repeatedly. So in this class, first of all I am going to explain you how that formula came, which is not important. Nobody will ask you to derive the formula because that is in your mathematics. But how this formula is derived, I am just going to give you the derivation. Thereafter you must remember the end result. So quite important for you is what is a geometric progression. First you have to recognize by seeing a series that the series in GP or in arithmetic progression, that is in FP. Then you need to find the infinite series sum or for finite series sum. So let us see that. Arithmetic progression, first of all we have to study about arithmetic. No one have studied about this in mathematics. Just I am just going to write this. The series is in FP. If the series will be like a minus b, a minus b, a plus b, like that. So this is the series which is in FP. So obviously this a is known as your first term. So here a is first term. If a is first term, obviously a is first term. Then we have sorry here you can see here a is first term. There are two things that you have to think. So you have to notice here one common thing is a and a minus b and a plus b. What we have noticed, they only differ by one common difference, that is your d. So d is known as your common d is known as your common difference. So what is important in this series, that is a is your first term, always remember, and d is your common difference. Then how to recognize, for example, 1, 3, 5, 7. So in this series you can see how to find the common difference. Common difference always calculated from the, you have to subtract the previous number from the succeeding number. So in this case 3 minus 1 that is 2. So 3 minus 1 that is 2. Then you have to subtract 5 minus 3 that is 2. So obviously then you have to subtract 7 minus 5 that is 2. So you have noticed here the common difference is 2. The first term is 1. So 1, 3, 5, 7. This is one of the example for your arithmetic progression. So in arithmetic progression, we have the series must be differ by only some common difference, that is constant. How to find that common difference? Suppose this is your T1 term, this is your T2 term, this is your T3 term. You have to subtract T1 from T2, subtract T2 from T3, like that. So common difference will be, for example, T equal to T2 minus T1, like that. So this is your arithmetic progression. So in this we have to remember one important formula. So if the series is in FP, suppose we have n number of terms, suppose we have n number of terms, that is in FP, then Sn is equal to, then sum of the, then in FP, then sum of n number of of n number of terms is equal to n by 2, where n is the number of terms, so into 2a plus n minus 1. This is the formula. You need to remember. Here Sn means Sn is the sum of n terms of series. Sum of n terms. Sum of n. Sum of n terms. Then we have the formula n by 2 equal to 2a plus n minus 1 into d. So d is the where d is the common difference. A is the first term. N is the number of terms. N is the number of terms. D already taken common. So D is the common difference and N is the number of terms and A is the first term. Now the question here given is summation of n is equal to 0 to 10, 2n plus 1. So find the sum. Find the sum. Find the value. Find the sum. So first of all, this sum is lower limit is n is equal to 0 and highest limit is 10, and we have given 2n plus 1. Then how to write? First of all, we have to put n is equal to 0, then n is equal to 1. So first and then we have to add. Okay? This is the summation of n is equal to 0 to 10. This is the summation of all the. So how many number of terms is present? 0 to 10 means we have total 11 number of terms. Total 11 number of terms. So first of all, I have to put n is equal to 0. Then I have 1 plus n is equal to 1. Then 2 into 1. 2 into 1 plus 1 plus 2 into 2 plus 1. So like that we have 2 into 10 plus like that. So we have 1 2 into 1 2 plus 1. Then we have 1 plus 3 plus 5 plus 21 plus 21. So we can see here 1 3 5 7 like that. So we have this is in FP and we have total how many number of terms? We have total 11 number of terms. So how I find the number of terms? Number of terms will give you the limit 0 to 10. 0 to 10 means we have total 11 number of terms. So just now we have studied the formula for this Sn is equal to n by 2 2a plus n minus 1 into d. So from this we have 11 by 2 because the number of terms is 11. 0 to 10 we have just count how many number of terms. There are only 11 number of terms. The first term is 1 here. This is your first term. So a means first term 2 into 1 plus n minus 1 again 10 into common difference is 2. 3 minus 1 2. 5 minus 3 is 2. So we have 10 into 20 plus 2. 22 divided by. So we have 11 by 2 into 20. So this will cancel out and our result will be 120. The result will be 120. So we have to solve like this. If the summation is given like this, this is in FP. So you need to remember this term n by 2 equal to 2a plus n minus 1d, where n is the number of terms. Where we find n? N is equal to here n from 0 to 10. That means we have total 11 number of terms. 0, 1, 2, 3, 9 up to 10. So including 0. That means we have 11 number of terms. Then the first term is a. That is your first term. D is the common difference. How to calculate common difference? I have already explained you that you have to subtract the preceding number from the succeeding number. So next series will be in your geometry progression series GP, which is very important. GP. So geometry progression of GP. So here we have AR square. Suppose A R to the power n minus 1. So here one thing you have noticed, the first term is A, and we have a common ratio R is multiplied with each succeeding number. So this term, how to find this? If this series will be like this, then this is the example of geometry progression. For example, 1 by 2 whole square, 1 by 2 whole cube, like that. That series will be in geometry progression by, because this is your first term, then A, that means A equal to 1 by 2. I can write 1 by 2 whole square like this, 1 by 2 into 1 by 2. So this is your first term, and this is your common ratio. How I find common ratio? I have already explained it. So this is your first term, means this is T1 and this is T2. So always take, for finding common ratio R is equal to T2 by T1 or T3 by T2 or T4 by T3, like that. So the ratio remains same. That's why it is known as common ratio. R is known as your common ratio. Common ratio. So now I want to find, if the series is in GP, then what will be the sum of n number of terms? So for example, suppose I have to calculate sum of, this is very important. So please note it down. Sum of n number of terms means we have just GP series having finite number of terms. That n can be 10, that n can be 11, 12, 15, anything. We have finite number of terms in GP series. Sum of n number of terms. That is Sn is equal to A plus AR plus AR square plus AR to the power n minus 1. So we can see here A into AR to the power n minus 1. So A means here A into R to the power 0. So R to the power, that series is starting from R to the power 0. Or something to the power 0 is always 1. And 1 is multiplied with A. That becomes A. So here the series is starting from R to the power 0 and ending from R to the power n minus 1. 0 to n minus 1. So we have n number of terms. That's why I'm written sum of n number of terms, that is denoted as Sn. So here the common ratio is R. For example, this is your equation 1. Then multiply equation 1 with common ratio R. So I have to multiply both the sides by common ratio R. Always remember, this is very important. Sn into R is equal to Sn into R. So multiply with the left side, that becomes Sn into R. That is here AR square, AR cube, AR to the power n. This is equation number 2. Just I have multiplied R with equation 1 in both the sides. And now subtracting equation 2 from 1. Subtract equation 2 from 1. So equation 1 minus equation 2. So notice here, I have to written like Sn minus left hand side Sn minus SnR, which is equal to, here we can see here AR cancel out, AR square cancel out, then AR cube cancel out, up to AR to the power n minus 1, AR to the power n minus 1 obviously going to cancel out. Then what will be remaining? We have remaining the first term A and the last term AR to the power n. Just subtract it. You can find this AR cancel out, AR square will be cancel out, up to AR to the power n minus 1. Then what is remaining? A plus A minus AR to the power n, because you are subtracting A minus AR to the power n. Then we have to take here Sn as common. Then we have 1 minus R which is nothing but here we have to take a as a common 1 minus r to the power n. So now the sum of n terms Sn becomes which is equal to which implies Sn is equal to what will be if here 1 minus r to multiply to this side, if I take this 1 minus r to right hand side, then what will happen? So we have a into 1 minus r to the power n divided by 1 minus. This is very important number. So if you have n number of terms, then what is the sum of n number of terms in GP? That is a whole into 1 minus r to the power n divided by 1 minus r, or alternatively you can write, because in numerator and denominator we should take minus as a common, then this formula can be a into r to the power n minus 1 divided by r minus r. So depending where the r will be less than 1 or greater than 1, we have to use the formula like accordingly. So 1 minus r to the power n divided by 1, where n is the number of terms. Remember, n is the number of terms. Where we find the number of terms? In the summation only. In the summation, that limit will give you the number of terms. For example, n is equal to 0 to 5. That means we have 6 number of terms. 0, 1, 2, 3, 4, 5. So obviously including 0 means we have 6 number of terms. So a is your first term, and r is the common ratio. And in a series, how to find the common ratio? Here you can visually, here it is visible that ar by a cancel out a, that is r. So how to find the common ratio? We have to divide the succeeding number with the previous number. That's how we will get the common ratio. So this formula is very important. This is for sum of n number of terms in GP. This is for sum of n number of terms in GP. What if the sum? Next please. Next is, this is very important, sum of infinite number of terms in GP. Sum of infinite number of terms in GP. So this is very important. So here we have, that means s of infinity, sum of infinite terms in GP, that is s of infinity, we have a plus ar plus ar square up to infinity. This type of problem we have arrived at the summation of n is equal to 0 to infinity a r to the power n. Summation of n is equal to 0 to infinity a r to the power n. If I open like this, which will become a plus ar square up to infinity. So how to find this sum? So we know the summation of n number of terms in GP is a whole into 1 minus r to the power n 1 minus r. So if this n tends to infinity, because here the number of terms, this is the summation for n is finite. But when I put s n tends to infinity, this series becomes, this r to the power n value becomes 0 only when we have this r to the power n tends to infinity, then r to the power n tends to 0 only when magnitude of r is less than 1. This condition must satisfy. Magnitude of r, that is mod of r, is less than 1. Then only r to the power n tends to 0. Otherwise r to the power n, otherwise r to the power n tends to infinity. That means if r magnitude is greater than 1, then this sum will tend to infinity. So hence, how to write this? So how? But you have to remember. So sum of infinite series in GP s infinity, which is equal to a by 1 minus r, a by 1 minus r, where magnitude of r is less than 1. This is very important. Or this is equal to infinity if R magnitude is less than this is equal to infinity. This sum is equal to infinity if R magnitude, that R means common ratio. If the common ratio is greater than 1, then this sum will tends to infinity. If the common ratio becomes less than 1, this sum becomes A by 1 minus R. A by 1 minus R. So this is very important. Student, please remember this formula. This is very important. Sum of infinite terms in GP. So we are going to repeatedly use this sum. Repeatedly we are going to use this formula. So this is very important. So S infinity is equal to A by 1 minus R, where R not less than 1, and S infinity is infinity if R magnitude greater than. So thank you. So in the next class we will see some problems on this.